Assalamu alaikum, dear students. I'm your teacher Gr11MS. You're welcome in our lesson Limits and Continuity Part 3A. At the end of this video, you'll be able to recognize and calculate the limit of a given function at right and at left of a given point. But before you start, please prepare your textbook, your pens, draft papers, your copybook, and your calculator. We have a summary of what we have taken before. Don't forget, before we start with our new objective. Activity 1. Let f be a function defined on the domain -infinity 1 union 1 plus infinity as f of x equals to x squared minus 1 over x minus 1. Let us complete the table below. To complete it, please pause your video and complete it. These are the values of f of x where x changes. Be careful, 1 is excluded, so f of x is 0 over 0. The result of activity 1, we can notice that f of 1 is 0 over 0. Since f is not defined at 1 according to the domain of definition, then we find the limit of f of x as x approaches to 1 from the left, where x less than 1 and x is very close to 1, and the limit of f of x as x approaches 1 from the right. That means x greater than 1 and x is very close to 1 from right, if they exist. Graphically, you can see how this is 1 on the number line. This is the value which is very close to 1 from left. As x tends to 1 and x less than 1, we say x tends to 1 minus, here x approximately 0.9999, where x approaches to 1 from left. But when we say that a number is approaching x from right, approaching x equal to 1 from right, we have as x tends to 1 where x greater than 1, we use the symbol x tends to 1 plus, and x here is 1.0001. We say x approaches 1 from the right. The result of activity also in the preceding activity, since f of 1 doesn't exist, then we shall find the limit of f of x from left, where x tends to 1 minus, and from right, where x tends to 1 plus. And we write it by this way. The limit of f of x as x tends to 1 plus equals to the limit of x squared minus 1 ala x minus 1 as x tends to 1 plus equals to the limit. We shall here, since it's 0 over 0, we shall factorize x minus 1 into x plus 1 over x minus 1, then simplify till we get the limit of x plus 1 as x tends to 1 plus, which is 2. The limit from left, which is the limit of f of x as x tends to 1 minus, by factorizing x squared minus 1 also, we'll get the limit as x tends to 1 minus of x minus 1 x plus 1 over x minus 1. By simplifying, we'll get the limit of x plus 1 as x tends to 1 minus, which is 2. Thus, the limit of f of x as x tends to 1 plus equals to the limit of f of x as x tends to 1 minus, which is 2. Therefore, we can deduce that the limit of f of x as x tends to 1 equals to 2, basing on the following property. The property says that in general, we say that the limit of a function f at a point A exists if the right and the left limits are equal. And we can see how we write limit of f of x as x tends to a where x less than a equals to the limit of f of x as x tends to a where x greater than a Or we can say that the limit of f of x as x tends to a minus equals to the limit of f of x as x tends to a plus. General interpretation. Look at the adjacent figure. The representative curve of f of x, which is x squared minus 1 over x minus 1. As x approaches 1 from left, you can see the x-axis, the 1 minus. F of x also approaches 2, and you can see it. As x approaches from right, also look at the x-axis at 1 plus, how f of x approaches 2. Application 1. Please complete the following table. Here there are some numbers, and you shall find the left of each number and the right of it. Please pause your video, then complete the table. Properties. When 0 minus is a number which is less than 0. When we say x tends to 0 minus means that x tends to 0 but it's less than 0. Example, 0 minus is minus 0.0001. So when we say 2 minus also less than 2, then 2 minus 2 is less than 0, which means that 2 minus 2 tends to 0 minus. In this case, if x tends to 2 minus, then x minus 2 tends to 0 minus. And here is an important property that where k is any real number and k not 0, k over 0 minus is minus infinity as x if k is positive, and k over 0 minus is a plus infinity if k is negative. On the other hand, 0 plus greater than 0, so if x tends to 0 plus means that x tends to 0, and x greater than 0, where 0 plus means plus 0.0001. And 2 plus is greater than 2, so 2 plus minus 2 is positive number. So 2 plus minus 2 tends to 0 plus, so if x tends to 2 plus, then x minus 2 tends to 0 plus. Here, if k is a non-zero real number, then k over 0 plus tends to plus infinity if k is positive, and k over 0 plus tends to minus infinity if k is negative. Example 1. Find the following limits. The limit of minus 3x over x minus 2 as x tends to 2 will give us minus 6 over 0. So remember, in this case, in case of k over 0, find the limit at left and at right. So at left, the limit as x tends to 2 minus 3x over x minus 2 will give us minus 6 over 0 minus, which will give us plus infinity. While the limit at right, as x tends to 2 plus, of minus 3x over x minus 2 is minus 6 over 0 plus, which is plus infinity. In this case, the limit at left doesn't equal to the limit at right, so we say that the limit does not exist. Another example, the limit of x plus 3 over x as x tends to 0 is 3 over 0, so the limit at left, which is 3 over 0 minus, which is minus infinity, the limit at right as x tends to 0 plus, which is 3 over 0 plus, which will give us plus infinity. And also in this case, the limit at left doesn't equal to the limit at right, so here we have the limit does not exist also. A third example of some calculations of limits using substitution. The limit of as x tends to 1 minus of 3x over 1 plus x squared. By substitution, you'll get 3 over 2 simply. the limit as x tends to -1 minus of 3x plus 2 over x plus 1. Here we want to find only at right, only at left, which is -1 over 0. To know if this 0 is 0 minus or 0 plus, we shall study the sign of x plus 1. We can find that it is before -1, it is x plus 1 is negative, and after it is positive. So we have at left it is negative, so it's 0 minus. So we have -1 over 0 minus, which is plus infinity. Another example, the limit of x plus 2 over 10 minus 5x as x tends to 2 plus. Here we want to find the limit at right of x of 2. So to find it, if this 0 is 0 plus or 0 minus, we shall study the sign of 10 minus 5x. At the right of 2, 10 minus 5x is 0 minus, as shown in the table. So the limit is 4 over 0 minus, which is minus infinity. The last example, the limit as x tends to 0 minus of 3x plus 1 over x squared. It will be 1 over 0 plus, since 0 minus squared is 0 plus, so it will become plus infinity. Application 1. Find the following limits. Please pause the video to calculate this limit. Another application. Also, please pause the video. The third one, pause also your video to calculate it. Coming next, we will recognize the piecewise function and define continuity of a function, then interpret it graphically. See you soon, dear students.